For this video, we're going to talk about the graphs of inverses. So before we learn that to find an inverse, you need to switch the x and y and then solve for y. It's just a little review. Notation for inverses was f to the negative 1. So if we were trying to find the inverse of this function, finding the inverse of function x, we would first switch the x and the y. Then we're trying to solve for y, so we gotta get y by itself to the cube root. There's a notation again for inverse. So basically, what we're gonna do here is I showed you how to do it algebraically. Now I'm gonna show you how to do it graphically. And to do this, we're gonna use the idea that we switch the x and the y. So basically, what we're gonna do is we're gonna flip this graph. We're gonna flip this graph over the y equals x axis. Alright, so here we go. It's important to realize that we have some points that we can work with. So for example, right here we have 0, 4. I know that because we started, this here is our parent function, x cubed, and we had a vertical shift up 4. So we started here, and we moved it up 4. Alright, so now let's flip this graph over the y equals x axis. Now, just like in the solve for the inverse, we switch the x and y. So instead of 0, 4, we're going to have 4, 0. And it's going to look something like this. Oops. Let me clean that up a little bit. And that there is our graph of the inverse. Okay. I'll do a couple more practice problems, then it'll be good to go. Alright, these are found on page 220 of your textbook. This is number 30 and 31, where it's asking you to sketch the graph of the inverse. So we're going to tackle this by, I like to just draw what I know first, so I'm going to draw my y equals x axis. We're going to flip this graph over that axis. So I'm just going to take each point. So instead of 3, 1, we're going to look at 1, 3. And instead of negative 3, 3, we're going to do, instead of negative 3, 3, we're going to do 3, negative 3. And now I'm just going to connect our two dots. And that's our inverse. Alright, so now let's do number 31. I'm going to first sketch my y equals x axis. Now I'm going to take a couple points and move them around. So we have one point right here. I think that's, I'm going to change my color. That's negative 1, 2. Then we have this point right here, which is 3, 6. I'm going to flip that over the y equals x axis. So, instead of negative 1, 2, I'm going to do 2, negative 1. And instead of 3, 6, I'm going to do 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. And there we have it. We got two functions, and we got the inverse of each function. Here we have a problem where it's asking us to sketch the graph of the inverse, and we have our f of x, and we have our axis symmetry. So now I'm just going to try and sketch the graph of the flipped, or the inverse. So if we try and flip this graph over the y equals x axis, pretty much fold it diagonally, it's going to look something like this. This is f of negative 1. Alright, now, does this cause any problems? Well, if we try to do the vertical line test, we see that it fails the vertical line test. That means that this is not a function. And since the inverse of f is not a function, that means f of x does not have an inverse. Alright, now after that last slide, it's good to talk about the horizontal line test. The horizontal line test says that if we can pass a horizontal line through any part of the graph and intersects only one time, that means that function will have an inverse. And if it passes more than once, just like it does here, passes once, twice, three times, once, twice, three times. If it passes more than once, it will not have an inverse. Okay, so if it passes one time, it will have an inverse. If it doesn't, if it passes more than once, it will not have an inverse. That's pretty intuitive. When we come into class next time, we will talk about what it means to be one-to-one or onto, and that's nearing the end of the new content. All right, so enjoy the rest of your night. I'll post the homework problems that you need to do.